guys, welcome to Rotor Riot. I'm Drib, and I'm joined today by Miss Creature. You may know her for some of her artwork that she's done for lots of companies and pilots, including this t-shirt that came in a quad box. So today we thought it'd be really fun to build a quad together. So what are we building? What is this thing here?
We are building the Sköll V2 from Flynoceros. I'm so excited because I have a lot of them, and this one is the Rotor Riot edition, and it's really sexy.
So it's like this one, right? This is a completed Sköll from Flynoceros, and it's even got, is this one of your designs, these skins?
Yeah.
Is your art on it again? So we've got the Sköll V2 frame, and to go on it we have DYS flight controller and 4-in-1 ESC, the immersion tramp video transmitter. We had to use the Rotor Riot Swift 2 and the best motors, my signature Drib hype trains. Let's get these things out of the way. And why don't you show me how this carbon goes together? So we have a bottom plate, and then I'm guessing there's a mid plate, and you're just gonna sandwich the arms between them?
Exactly.
Okay, so we've got these two plates, and they're gonna sandwich between the arms, but then also these 3D printed pieces have to fit in there too?
Exactly.
Okay, so this is already a little bit different for what I'm used to. How do these go in?
Yeah, I always get confused, but it's
Okay, I see it. So then you've got, this is the middle plate and this is the bottom one?
Yes.
Okay, so then you want the curve.
Yeah, check, the bottom guy.
Okay, actually that's going to be really nice because now it's kind of held together, so then when you go to insert the arm, it's kind of all held like that. So yeah, we got a couple different lengths in here. The longest screws are what you're going to need because it's going through the most carbon. You've got 2 plates plus the arm. So find whatever's longest. Let's check.
Do you have a preference on which to have the nuts on the bottom or the top? This time I switched it.
You can actually do whichever you want. I just kind of prefer the button caps on the bottom and have the nuts on top, just because you have to have the caps on the bottom for some of the other ones, so it makes it kind of more uniform throughout if you do it that way. You can totally drop the screw through rather than feed it up. Either way is going to be fine. Yeah. Right? So you got the bottom plate and your 3D printed pieces in there with standoffs in there. Okay, and then your middle plate, screw goes up through, you fit the nut, and I like how the arms kind of all interlock in the middle, so then once we insert this 4th one, it should be pretty rigid. Alright, so everything is kind of loosely in there. I think we can snug it up a bit, but you don't want to tighten it too much because you might still need to have a little bit of wiggle room, but let's just get it so they're not wobbly.
Yeah, the good thing about this one I noticed is like whenever I do it, I actually can snug them all down because I've never had to like refix it or anything. Yeah, because it's just the bottom plate, everything else is really straight.
Oh, does everything else kind of go on these pieces then?
Yeah, this whole thing, like the other bars are gonna like clip into this and then it like retracts out.
Okay. Alright, all 4 arms are installed. We've got everything tightened up. We can start doing the electronics on here, right? Because then this can just go around everything. Alright, so I like to always get the PDB or the 4-in-1 or whatever you're going to be soldering to mount it and kind of go from there. So we are using a 4-in-1 here, which makes the build really nice because rather than having to solder your motors to your ESCs and your ESCs to your PDB, you just go motors straight to your board in the center. They've got them labeled, if you look really closely, it says M1, M2. And since this is going to be a beta flight build, we know that for the rear it's 1, 2, 3, 4. So we will orient like that. Yeah, and then you don't have your ESCs on there. So see on this one where you use individual ESCs, it's nice that you had that protection because you got.
I had a problem with that.
Oh, you chopping it? Yeah. You should still do that because you can chop the wires.
Yeah.
But if you damage a wire, then you can usually repair it with a little solder and electrical tape. Whereas with an ESC, if you hit that and knock off components, the ESC is usually toasted, so it's a little bit more expensive than just fixing some wiring. For the 4-in-1, you also want to think about how the flight controller is going to mount on top of that. We've got the matching DYS flight controller.
I was wondering about that.
Yeah, it's cool because you can actually use this as a standalone flight controller or with their 4-in-1 system, right? So they've got these solder pads so the ESCs can connect directly to it, or when you want to use their 4-in-1, they've got a breakout cable on the bottom of the flight controller, and you just have a jumper that hooks over. Now, both of these things, they come with all these nylon pieces.
Yeah.
Which is great because they give you everything you need. The unfortunate thing about nylon, I find that the male stems are pretty prone to breaking. I mean, it's really flexible, and if you're going to be crashing, you're probably going to break the threaded portion. This male end is what's going to break. So, kind of what they would have you do is screw this female to male down to the flight controller, then you would put your 4-in-1 on top of that, then you could put another one on top of the 4-in-1. Then the flight controller would sit on top of that, and then you would screw it down. And that works great, but I found that it's just too fragile. It's just, totally. It's gonna break when you crash. I mean, and if you have to set it up this way, if you don't have anything else available, that will work. But something that I really like to do is use some long screws that we're gonna pass up through the bottom plate. Then we're going to thread just one of these female spacers. The hole goes all the way through, so you can thread that all the way down. Then you're gonna be able to drop the 4-in-1 on top of that, put another spacer on the 4-in-1, and then put the flight control on that. So you'll see how that comes together, but it's way more durable because the metal screw is so much less likely to break.
Makes sense, yeah.
All right, so I put the 2 diagonal ones in because what I want to do is I want to test fit for the components on the bottom of the ESCs. So I've put just the nut, kind of the smaller piece, right? They've got these taller spacers as well as these smaller nuts. So what I want to see is, are we going to be able to put this ESC down on just those nuts without it touching the carbon fiber? And it looks like everything clears pretty nicely, and then it's nice and low. You'll get to keep your wires short. Go ahead and put the other 2 long screws through so we can drop the 4-in-1 on. So drop it on there so that the motors are all lined up. One's in the back right corner.
Yep.
Yeah, that's right. And now the next thing we do is bolt the motors to the arms and just lead the motor wires right to the 4-in-1, because we can't put the flight controller in place, because if we do, it'll make it kind of hard to solder the motors on. So we'll do the motors next, and then once the motors are in place, we'll put the flight controller on and go from there.
You solder everything while the board is on here, and you don't do it loose at all?
No, because you don't have to measure it then, right? So if you did it loose, you'd have to pre-measure everything, and this way the frame is doing the measuring for you. You just bring it so it's tight, maybe back it off a little bit so there's some slack, and then solder it down.
Oh wait, do we Loctite the motors?
I don't use Loctite just because it's an extra step, but since you asked, and because it's the right thing to do, let me grab some Loctite. Blue Loctite, that comes in a red tube for no price. I just hate this stuff, it gets everywhere.
But I know how you use this, Drew. When you use Loctite, you squirt a glob on the table, which he's just about to do.
He puts it on the table?
He puts a glob on the table and then dips his bolts in there. And the technique works, but it's sloppy. It's sloppy, but even if you try to be clean, because I do try to be nice and neat, it still ends up super sloppy and doesn't really work.
She's really good at it though. Okay, she puts the screw on the table and then uses that. I'm always dumb and I'm like, okay, we're gonna try and hold it just ever so, and then I dip it in there and then I get on my fingers and then I'm like, oh, it smells good, and it tastes horrible. Don't eat Loctite.
That's why your hair's blue now.
That is what happened.
Don't do Loctite, kids.
All right, everything is bolted down. So the next thing we need to do is just solder the motor wires to the 4-in-1. Just bring the wires straight to the pads. Don't worry about what direction the motors are going to spin.
Yeah,
back in the day we'd have to flip the wires and so on. 2 of them, you'd have to cross them and figure it out in advance, which can be what, blah blah. It's all sorts of annoying. But now we've got great configurators on the computer, so we'll just solder, left to left, right to right, middle to middle. Yeah, you want to leave a little slack, so I'll probably leave that one as long as it is. Then the middle one, and cut a little bit off here, and then this far right, cut it like there. So on the ones where I cut off the pre-tin section, I need to strip it and tin it myself. And then even this one that still has the tinning that came from the factory, I always like to put fresh solder on. So we're gonna tin the bare wire here. So you hold the iron on the bare wire and then feed the solder into the other side of the wire. That's how I try to ensure that the solder flows through the wire. If you kind of need to cheat it by like touching solder to the iron to get a blob on it, but then just make sure that you get the solder to the other side of the stripped portion and feed it through like that. And then like I said, even this one that's pre-tinned from the factory, we're still gonna hit it with some fresh solder to make sure that it's all congruous. And now we're gonna pre-tin our pads, so you just hold the tip of the iron on the pad and then feed the solder onto the pad. Again, if you need to cheat it by touching the solder to the tip to kind of get it started, it's fine, but then just kind of, there you go. That's a nice ball of solder. That's what we want to see. Now that the ends of the wires are tinned and the pads are tinned, we'll grab our tweezers, hold our wire, and we're going to solder them together. What I like to do, depending on if you're left or right-handed, is go the direction so that your tweezers aren't going to have to cross over any of the wires that are already done. So if I did this wire first, then when I went to do this other one, the tweezers would be hitting this wire over here. So we're going to start with the wire that's on the inside. Really nice if I had some sort of magnifying device. I'm just trying to get my face nice and close. I think it looks good with my human eyes, so that's going to fit there. Yep, I think we'll be good.
I found it to be mostly the back that you want to think about rather than the front, because it actually pivots up and down. You did it like this in order to get in here if you need to.
Okay.
Yeah.
No, it's a good thing to check. Just keep pre-fitting and pre-testing things every step of the way, because nothing is worse than like soldering up a bunch of stuff and then you go drop a standoff and you're like, great, that's right over where my wires are run. Mm-hmm. So you can't really be too cautious.
I don't strip wire with my teeth. How do you strip wire?
With your teeth? What's up? How was it with his teeth?
Yeah, when you're working on cars and stuff too, you just
I just do it with my thumbnails.
Really? I can't do that. Oh my gosh, I cannot do that.
I don't have thumbnails.
I have thumbnails, but like pinch.
I mean, they have tools for this, but like.
Oh, I did it!
Yeah. Oh, this one I think you might have cut a little bit too short.
No!
It's all good. We can fix it.
Can I swap it?
We have the technology. So we got this piece we're going to extend with, and we've got the wire that needs extending. So we strip a little wire on both ends, and then what I like to do is just feed them together like that, so they kind of get interwoven. Just kind of butt them up and pinch them. Grab your solder and your iron. It's joined together and it's not too thick. If you had stripped off a lot of wire and then twisted it together, you get like that ball, but just by kind of like pushing them together like that.
Go into all of that, like all into the weave?
Yeah, yeah, and so then once it's in, I mean, it's not the, NASA would tell you, it's not a strong joint, and then once in the rocket, so if you're ever soldering for NASA, don't do that. They want you to do like this crazy weaving thing.
Right.
But for a mini quad, yeah, just mash it together, heat it up, just get a little piece of heat shrink right there. Slide that over. And since I'm using a lighter, I'm just gonna bring the wire over the edge of the table so I can get under it with the heat. So you just like if you go straight to it, like you know you want it to lay against the carbon. So rather than like pulling it tight, and making a straight line, push it down against the carbon like that. So you can have some wax. Now you've got some slack in there.
Okay.
When it's held, just cut it like right there.
Oh my gosh.
Kidding. Solder it up. All right, so we've got the 4-in-1 ESC board mounted, got the motors attached to the arms, and the wires run down and soldered to the 4-in-1. Now we're going to drop our flight controller on top. And you can always remap the motors, so in a sense it doesn't really matter orientation, but it just makes things a lot easier if you do get everything right and saves you a step later. So we're going to make sure that we find motor 1.
Could you look at anything else?
You can look at the wiring diagram, right?
Okay,
so they give you this wiring diagram and they tell you which is which, right? So down here it says motor 1 and the XT60 is coming off the left side. So we just know that XT60 always coming off the left side. And then we look on here and we've got ourselves a nice forward arrow, and also that's labeled 1, so just make sure the 1 goes on top of the 1. So to drop that on, we need to put these spacers down on threads. So we'll take these and drop those on. And then also, this board is really nice because it has enlarged holes, and then you put these rubber grommets in there, and then that isolates the gyro from vibration. Try to pinch it, insert it down through here, hold it from the underside, reach up top, grab it, pull it through. We're gonna now double check that everything is clearing everything. So we're gonna, even though we checked it earlier, we're gonna kind of hold it so we can see the bright table through, and we're looking that all the components on the 4-in-1 board aren't touching the carbon fiber, because carbon fiber is conductive, so you don't want anything shorted out. And then we're also looking to make sure that the components on the top of the 4-in-1 aren't touching the components on the bottom of the flight controller. Next thing we do is we grab our package of pigtails, and since we have the DYS flight board and the DYS 4-in-1, there should be one here that will just be plug and play. So we've got this bigger connector for the 4-in-1.
Why do they offer so many? Just because there's different
Well, they've got different options, right? So like if you're using their large 4-in-1 with the smaller flight board, I think that's probably for one of them. Yeah, just for different options. I mean, then they give you this one that's just doesn't have a plug on the other side, so that way you can insert it and then solder it up to any board that you might have. It should only go in one way, so if you have it the wrong way, it won't go in easily, so don't force it. Like, you know what I'm gonna do, because the connector on the foreign one is on the side, but on the flight controller it's on the front. Rather than looping around like that, what I'm going to do is I'm going to lift up the flight controller.
Twirl it?
I'm going to loop it under
nice.
that. So now we've got the plug in the side of the foreign one and in the front of the flight board, and we're running it kind of like that over the top of the foreign one. We're just going to fold that over to hide the wiring, and look how clean that looks. It's great. And those screws are really long, right? We totally could have used...
I know, I was wondering about that. I was wondering about the clearance on the battery top.
Just cut them.
Oh, yay! We see, at home we use a grinder.
Oh wait, I don't want any part of that.
Put the nut on first.
I don't know if this is...
I don't know if that's going to be...
I don't know if I have a good enough cutter. Okay.
Yeah.
Let's put the nut on.
Oh, gosh.
It's going to be fine. What are you worried about?
Nothing. Why would we put the nut on first?
Because I've damaged the thread.
All right.
What he's dealing with right now.
When you screw the nut on, you don't want to over compress that grommet. So you want to snug it up, but you see how the grommet hasn't actually deformed.
Yeah.
So then you've got good soft mounting without, if you over compress it, you kind of defeat the purpose. So now we're going to see if this is a horrible idea or not.
Oh, woo! You don't have to normally do this.
No, just use
just
screws
wanted
out
to
of
be
the right
fancy.
length. You know, I'm trying to screw down. Anyways, we're going to start attaching the FPV components. Your camera and your video transmitter.
So I like to put the camera in the whole top plate first because it like squeezes in
Okay.
when you tighten it all.
You got these side plates, and this is kind of where you mount the battery, right?
Yeah.
So that just inserts here, and then you hold it together with standoffs.
Yeah.
And I think,
Definitely.
okay, this is for
The
if you
back,
want to
yeah.
mount your...
Before you tighten it all up, throw that in there, and
Okay.
that'll be where your antenna will come out. I've also put my battery through it on the old one.
Oh, okay.
Both wires, but then I found it a little better when it's mounted to the side like this board allows.
Yeah. Okay, so this on the rear section, these front holes will go through the standoff that's inserted
Pivot
into this.
master, yeah.
Okay, and then similarly up front, so that'll sit up there, but you hold the whole thing together with these other standoffs in the other places, okay? But before we get it too tight, we should get the camera in place,
Exactly,
right?
yeah.
So we've got 3D printed pieces that attach to the camera, and then those pieces get squeezed by the frame, huh?
Exactly, yeah.
Okay.
Now you have to squeeze it into here, and I like to keep it a little bit tight so that it actually, because it can all
It'll
fall
just pop into
through.
place, okay. Rotor Riot skull side up, connectors on the top, and we're just gonna try and fit this in here. Then you can tighten down the standoffs to bring the whole cage into a state of rigidity. That is a really nifty design because then the 3D print puts pressure on the sides of the camera, so it really locks it in place pretty well.
And less vibration will go through the camera too. And
Yeah.
you don't notice it as much when you're flying, but
Yeah, it's kind of like a soft-mounted camera, and then if your camera comes loose, you can always kind of tighten it up a little bit. That is, it's pretty nifty. I think another standoff goes back there.
totally, yeah.
Alright, so we've got our upper cage assembled with the camera in place. These holes kind of toward the middle are still open to screw onto our 3D printed piece there. I think because that's where your SMA is going to come out, it'd be really cool to stick your tramp right up here. But again, we just kind of want to test fit that when it's in that place, it's not going to interfere with the stack. So I'm just trying to trim things in there to see how it might fit. And it looks like, yeah, we're going to have plenty of clearance. Is now I'm trying to line things up and it won't go where I want, so it's going to end up further in than I originally wanted. So what we're going to do here, we're going to cut away the stock heat shrink and the stock glue. We're going to flip that connector around. It's nice that it comes glued, but if you want to change the direction for routing things differently, a little unfortunate. These small connectors can be finicky, so you just really carefully get it lined up. There, it's in place.
What do you do about if that pops off while you're flying all the time and it's a big issue?
So you can, glue it down, so like it came from the factory with all that glue, so it was really nice and secure. But what we're gonna do is we're gonna wrap a zip tie around it, so when we're gonna stick it with some double-sided tape, so it's down there, and then we're gonna put another zip tie around that as well, so that it should be held down nice and securely. Now that the pigtail's coming out this way, it can just flip up like that. So we'll insert it into the back here. That looks good there. And then we'll just run our zip tie around the tramp and that connector.
Do you guys call them zip ties?
What do you call them?
We call
Oh,
them
cable ties?
Zap straps.
Zap straps?
Yeah, the zap strap.
I like that better.
Zap.
So we've got one zip tie back here, but I'm also going to add another one up front just to make sure it's extra secure.
Do need one more standoff. Just looking at it because the GoPro needs 2 standoffs to bolt onto.
So I think the best thing to do to ensure that you have like all the slack that you're going to need for future repairs is actually bolt it up and then hinge it open and assemble, because we've got the video transmitter and the camera mounted to the top plate. We just need to connect the wires. So I think to be sure that we're going to have enough slack in the wires, let's attach it to the rear there. Got it hinged on the rear, so we'll have to slide this back off the end here so we can open it up. And then now we'll plug our tramp connector in, and we're going to remove a couple of these wires. So the red one is going to power the tramp itself. The black one is for the ground. We've got this orange wire, and that's for if you want to use the 5-volt regulator that's built into the tramp to power the camera. But we have 5-volt power on the flight board, so we're not going to use that. And we can just kind of lift up plastic piece holding that, and pull out that orange wire to keep it really clean.
Oh, I didn't know you could do that.
Yeah, just depend it. We got yellow for video. That's going to go to the flight board. We're going to keep that yellow one intact. This white wire is your telemetry wire, and that's going to let you control your video transmitter using your flight board. And this green wire is audio. Do you fly with audio? Do you want to hook up a microphone or anything?
I actually wondered about that. I don't know anything about that.
Yeah, I mean, it's not hard. What's really nice is this camera has a microphone built into it. So there's a wire for audio coming out of the camera. And we can just splice those wires together, and then you'll have audio. I personally don't fly with audio, so I usually just remove that wire. But if it's something you want to try, it's not hard to hook up, but I just kind of think it's distracting. So now we have all the wires that we're going to need: power, ground, video, and telemetry. We'll plug that into our tramp down here. The other thing you connect to this tramp that you can connect to the tramp is this guy, which is a near-field communication tag. So that can plug in into the other port on the tramp, and then you can mount that somewhere. And if you have the immersion wand, you're able to change channels without actually powering up your quad. So if you have one of those wands, but if you ever get one, just plug that in, maybe mount it to the arm or something like that. And it's really nice because without the quad even plugged in, you have this wand, you can set the channel, tap it. I don't use it, but it's a nice thing.
It's good to know.
Now we need to consult the wiring diagram, see where things go. Now this diagram, it has you running, it says over here, smart audio for VTX, so that's where they say that you can connect your telemetry wire. But if you look over here, that's where your video out is and where you have a positive and negative battery. And so I think it'd be really annoying to have 3 wires going over here and 1 over there. So if you look, there is actually another UART, which is UART3, available to you right there. So instead of using TX6 over here, we're going to use TX3 over here. And so then we can run all 4 wires to the same area on the board. So something I'll do is I'll just kind of hold the wires where they're going to go to on the board, leave a little bit of extra slack, and just I'll cut them. So what I'm going to do while you pre-tin them is I'm going to pull these wires off to the side, because what you don't want to do is be pre-tinning with them hanging right over the board, because if a blob of solder drops on the board, you can ruin some components. So I'm just going to pull them off to the side. Or you can also just take something like this piece of paper and put it over the board, and then if any solder drops, it won't get on the board.
Smart.
So hit all those wires with some solder to get it. We've got the ends of the wires pre-tinned very nicely. We're going to try to insert the wire into the hole. Now this one is just a little bit longer than it needs to be. I don't think it would hurt anything. That's totally okay. You can always strip off more than you need, tin it, and then after tinning, go ahead and just cut it down a little bit. There's nothing wrong with that. So don't feel like you have to get it perfectly right, because you can fix that really easily. So with the wire tinned and the pad untinned, you can just kind of insert the wire into the hole. So we got the wire just inserted to the hole with no solder, and then now we're just going to apply solder to that. So that's kind of like my favorite way to do it when the first time you're doing a build. But let's say your pad already has solder on it because maybe you're doing a repair or something. So for this ground over here, I'm going to go ahead and pre-tin it. So now I've already got solder. Get yourself a nice pair of tweezers or very small pliers. And we're just going to poke it, that pre-tinned blob of solder, you get that hot, and we're going to poke the wire right on top of it. We're going to add heat, and we're going to try to push the wire into the hole. If we get lucky, we'll insert just like that. So you can still get it, it's just a little bit easier when you're doing it the first time. So again, for the telemetry wire, we're not gonna make it harder than it needs to be. We're just gonna insert that into the bare solder hole. and hit it with some solder.
And is it okay if it burns back some of the sheathing? Is that what it's called? What's it called?
Yeah, you want to avoid that, but what's nice, I mean, when these components usually come with silicon wires, it's if you're burning back silicon wire, you're way too hot.
Okay.
But some of the components, like honestly, my Spectrum receivers, the coating isn't silicon, drives me crazy. I've been asking them to change it, and yeah, that'll melt back, and then I usually will cut it. And so when I'm soldering up something that doesn't have a silicon wire, I'll make the wire way too long because I'm like, I'm probably gonna mess this up. And so then when it burns back, cut it, try again. And the secret to that is just trying to move fast enough. So like I said, use actually a hotter temperature than you think you need, so you can just go in and hit it.
Quick, yeah.
Because if the longer you hold it, the more the heat's gonna travel up in the wire and melt that sheathing.
Right.
But that's what's so nice about this silicon stuff. So why don't you do the video wire for the video transmitter, and then we'll get the harness for the camera, and I'll have you do that too. So, all right, so we've got the video transmitter all hooked up. What we need to do is find ourselves a camera wire. We got all sorts of crazy harnesses, but we're just gonna find the simple one that's just power, ground, and video. Don't lose this remote that comes with it, because by default this camera comes with an on-screen display that will show you a timer and battery voltage, which is a really neat feature. However, if you're using one of these nice flight boards that have on-screen display built into it, it's redundant. So before we actually go out and fly, we're going to make sure to plug in this remote and turn off the camera's on-screen display so that we were using the flight board's on-screen display. So we'll get back to that, but for now here is just the camera wire, which again is really nice silicon. And this one's gonna run a little bit longer, I think, because the way we have this, the hood of this car quad thing opening up, we're raising the camera up. The bonnet. This simple connector that just has power, ground, and video, it is a lot narrower than the total connector that has power, ground, video, audio, battery voltage, all that stuff. So just make sure that you line up the red wire with power. So we're just going to get that all the way to the far side of the camera, plug it in, make sure that we have enough slack so that it's going to be able to close. Because what I don't want to do is I don't want to make it so loose that when we close the wire comes out the side like this. So the idea I'm having is to take this zip tie and tie the cable down to the battery plate up here. So now when we solder this and we close it, slack of that wire isn't going to be poking out the side, so we can keep testing. This is really cool how it opens like this. I think this will make it pretty slick to work on, and if you do need more room, you could always unbolt it and pull it out to the side.
It makes it not seem so scary to take it apart when you need to fix something.
Right, so we're just kind of holding it where it needs to be. We see how long the wire will loosely be, and we'll just give it a snip. Go ahead and strip these wires, pre-tin them, and then solder them up to these 3 pads, which is 5 volt, ground, and video in. The camera can run on 5 volts, but make sure that the video transmitter is running on a higher voltage, which is why we soldered it up here, which is a filtered battery source. But it's nice that these camera wires can all be together right there.
Wow.
So now we're just gonna double check everything. Ground, 5 volts, video in for the camera. Looks good to me. All right, we've got the frame assembled. We've got the motors on and soldered to the 4-in-1. We've got the flight board plugged into the 4-in-1, and we've got all of our FPV gear soldered up. The very last thing that we need to do before it is flyable is get our receiver. And we got you an X4R. This one comes naked, so we don't have to rip off any of the pins to make it easy to work on. Of all the pins, we really only need 3. We just need power, ground, and signal. They've got all these pins labeled, and so this top row of labels corresponds to this top row, this bottom row corresponds to this bottom row, and we have minus for negative, plus for 5 volts, and SB for S-bus. So we're just going to use 1, 2, 3. And hook those up to your flight board. This is the wire that comes with it, and this is not silicon stuff.
I know, it's hard, you can't.
I don't like that.
Yeah.
So here's what we're gonna do. We're not even gonna use it. We're gonna take some of our camera wire, because the camera came with a few different harnesses. So we're just gonna take this harness that we didn't use, and we're just gonna cut the connector off. So now we'll solder these wires to your receiver. So now we're gonna figure out where we want to stick this thing. Yeah, let's do that. Let's do it to the bottom of the deck. Would have been good for us to have realized that and done it before we bolted it on. But we'll just we'll make do. Just grab some tape. Alright, just stick it.
Yeah.
Get ourselves one of them. What do you call them?
Zap strap. Come on.
Zap strap. So with that in place, we can just twist these wires together. If you look over here, that's where we want to solder our receiver to. So we have 5 volt in the ground, and then right up here we have RX1 that's labeled for S-Bus, so we can just use those 3. For the non-ground wires, I'm using about 390 or 410 degrees Celsius. And for these ground wires, I'm turning it up as high as I can go, which is 450. So our soldering should be all done, but you've been preaching patience. Because of that, we are gonna test everything before we do the initial plug-in. So what I have here is a multimeter, and this has a really cool mode on it, usually indicated with like a little volume looking type thing. We turn it to that, and it's a continuity tester. So meaning that when there is a connection, the thing is gonna beep. Hear that? So if there's continuity like this metal table, gotta beep. But if there's no continuity like this wood, which does not conduct electricity, no beep, no beep, no beep. Metal beep, wood, no beep. So we're gonna take this to our flight board, and what we're gonna look for is any shorts that might create a problem. So I'm gonna put one of the test leads on a positive pad, and then I'm going to put another one on a negative pad. We got ourselves a problem.
Oh my god.
We got ourselves a problem. Why you gotta be like that?
I was just wondering, I was like, how long are we going to be able to go before we have a build that we think everything is good, we plug in and it goes up in smoke?
I'm finding continuity between ground and positive, so there's a short.
Isn't that exactly where it's supposed to be?
No.
No.
It's continuity without any resistance, basically, which means that if you plug a battery in, it's just gonna burn things up.
So what we're doing now is we are removing, unfortunately, every component. Once everything that we've soldered to the flight board is disconnected, we will be able to determine if there's a problem with the flight board itself, or if something that was plugged into it was doing something really erroneous. So now it's got nothing on it. I have full visual on every pad, and I can see very clearly that there is no ridges, and the board is toasted. We unfortunately don't know why. I hate to say it, but it's kind of part of the game, guys. At some point, this is gonna happen to you. If you build enough of these things, you're gonna put the whole damn thing together. And I know it's frustrating, especially if you're kind of getting new to this and you don't know if it was bad out of the box or if it's something you did, but charge it to the game, get another one. And here's what we should have done, is we are gonna test this before we solder it to anything. Positive, negative, we've got no continuity. No. Continuity when they're connected, no continuity. So we know now that this board is good. We aren't sure if the one that we just removed was bad out of the box or what happened, but you gotta suck it up and move on, boys and girls. All right, we've got all the soldering done. Let's grab out our best friend, the Mr. Beep Beeps. Oh, wait, are you kidding me? Wait. Okay, no, that was just me. Oh my god, I swear to god, I think I just touched. Alright, we're good. Nothing. Alright, so start by testing the full LiPo positive and negative. We have no continuity. You can also test that at the connector itself. So no beep, we're good. The next thing you want to test is the filtered LiPo power itself. And the last thing you want to test is continuity between 5 volts in the ground, and we have no beep. There's continuity between the 2 5-volt pads that we used, and there's continuity between all the ground pads that we used. Everything is looking really good. I'm just doing a couple other spot checks, and I think it is time for us to actually plug in a LiPo. If you have a smoke stopper, it can't hurt to have that on there for the first plug-in, but we don't got one, so we're just gonna plug it in. Do you want to do the honors of the first plug-in?
Yeah, I do.
Fingers crossed, guys. No smoke, no heat. All right, we are good. Last thing that we have to do is secure our RX antennas and install our GoPro. Because we're using a diversity receiver, you want to take full advantage of that, and you want to have them oriented 90 degrees to each other. So this portion of the antenna that isn't sheathed, That's the actual part that's doing the receiving. The rest of it is just to give you some extension to get it away from the carbon fiber.
Right.
Because carbon fiber is a conductive material, so it will block RF, so you want to get those kind of far away. What doesn't block RF though, hardly at all, is plastic, zip ties, electrical tape. So what I see a lot of is I'll see people do the trick where they take zip ties and heat shrink to secure and position their antennas, but they actually leave this portion exposed, and that makes it very susceptible to getting damaged and getting bent over. So you do want to actually have that covered. So what we're going to do is we're going to loop a zip tie somewhere, and then we're going to heat shrink the antenna to the zip tie, and we are going to cover the sensitive portion with that heat shrink so it's protected. Once the heat shrink is actually shrunk, it could still pull off, but something that I've found that will make it much harder for the heat shrink to pull off is to just take a little teeny piece of electrical tape, wrap it around kind of the end portion here. That's going to reduce the chance of your antenna slipping relative to the zip tie. It's going to reduce the chance of your heat shrink coming off, because once it shrinks, it's going to kind of grip the thickness of that tape. So you'll see once we get that on there, you can see that bulge where we put that tape. It's not going to slide off. See, when they're like this, we can just kind of bend them so that they're at a 90-degree angle to each other. So we assembled this puzzle of a frame that came out really cool. We've got some Drib motors installed, soldered to a 4-in-1 ESC attached to a flight controller. We've got all of our FPV gear in place, receivers mounted with the antennas oriented in a really nice way. I'm just gonna run over this thing with my driver and just double check that everything is nice and snug. The last thing to do is get a GoPro going. Yeah, this is a TPU piece, right?
Yeah.
So it's a little bit...
And there's angles, right? So you can like...
These slots kind of snap on to the standoffs here?
Just snap it on.
Okay, so I can see.
Yeah.
So if you have this bottom one that's going to be a little lower angle, let's try and snap it onto that one. So you just kind of have to force it on. So that's it. So now once that's on, what do you do next to get the camera in?
Let's say pop this guy in.
Look at that.
Put her in there.
Oh, that's so cool.
Solid.
So then the GoPro's like totally encased in this like protective thing and surrounded by carbon fiber. That fits really nicely.
I have smashed some gnarly things, and my GoPro has always survived.
You've never broken one?
No.
That's pretty impressive. This is pretty sweet. All right, so this is it. This is the Flynoceros Sköll Rotor Riot Edition, fully built. Thank you for showing me this frame and building with me. This was a ton of fun. I hope you guys, I hope you learned something here.
A lot.
I hope you guys learned something.
And a huge thanks to everybody at Rotor Riot, Quad Camp, Flynoceros, Broken Prop Crew, everybody for helping me with all of this.
All the parts for this build are in the description if you'd like to build one just like this. The last thing to do after a long and enjoyable but still exhausting build is get some props on and actually fly this thing. So let's get it out there.